So the question is, let f from closed interval ab to r be a function, sorry, non-constant continuous function. uh, then show that f of ab is uncountable. So we have to prove that the range of this function is uncountable, provided that the function f is non-constant and continuous. So let us prove this. So given information, f is a function from closed interval ab to r, okay, and this function is non-constant plus continuous function, continuous. So what is our target? Target is, we have to prove this, we have to prove that f of closed interval ab is a uncountable set. So the range of f is uncountable, that is f of closed interval ab uncountable. Okay, now, so what is the definition of a constant function? If we take, this is domain, this is our codomain. So the definition of constant function is, the picture of constant function look like this. So here given that the function is a non-constant function, so in the domain there is at least two member. In this domain there is at least two member, इस डोमेन में एटलीस्ट दो ऐसा मेंबर रहेगा जिन दोनों का ये जो इमेज है ये डिफरेंट होगा. Why? Because the function is a non-constant function. So let us say that these 2 points are x1 and another one is x2. So इस डोमेन में ऐसा 2 एलिमेंट है x1 एंड x2 जिस दोनों का इमेज डिफरेंट है. Why? Because this function is non-constant function that is given. So we write this, just a minute. Okay, since the function is a non-constant function, then there exists x1 comma x2 belongs to the closed interval ab such that the image of x1 and x2 are different, such that f of x1 not equal to f of x2. Okay. And see, the function is continuous all over the domain. The function is continuous on closed interval ab, and we take 2 point x1 and x2 from ab, then we can say that the function is also continuous on x1 comma x2. Okay, so just a second. Without loss of any generality, we assume that x1 is less than x2. So without loss of any generality, assume that x1 less than x2. Okay, you can assume that x2 less than x1. So जो तुम्हारा मर्जी यहाँ पे एज्यूम कर सकते हो. So I assume that x1 less than x2. Now since this function is continuous on closed interval ab, then this function f is also continuous on closed interval x1 comma x2. Why? Because x1 and x2 both points are belongs to this closed interval ab. So this function is continuous on this entire domain then this function obviously continuous on this domain because this is a subset of this. Okay. तो यहाँ पे हम लोग आई वी टी प्रॉपर्टी अप्लाई करेंगे. यहाँ एफ ऑफ एक्स वन इज नॉट इक्वल टू एफ ऑफ एक्स टू एंड एफ इज कॉन्टिन्यूअस ऑन एक्स वन एक्स टू दिस इंटरवल. So we apply here IVT, intermediate value property, intermediate value theorem. Okay. So intermediate value theorem क्या कहता है कि if this function if assumes all the value in between f of x1 and f of x2. Okay. This is also known as the standard IVT, standard intermediate value theorem, that says that the function f assume all the value in between f of x1 and f of x2. Okay. So now see here. So by IVT we say that just a second, f of x1 and f of x2. Okay, f of x2, these 2 points are in the real line because the function defined closed interval ab to r, the codomain is r. So this is a point in r and also this is a point in r. Okay. So f of x1 and f of x2, in between this point there are uncountably many points, infinitely many points. So we can say that since f assume all the value in between f of x1 and f of x2, then we can say that f assumes uncountably many points in between f of x1 and f of x2. So what we can say? We can say that that is nothing but f of x1 comma x2, that is uncountable. So if we extend this set, then we can say that that is f of a comma b is uncountable. So this proof this theorem. So basically here we apply just IVT theorem and